Good afternoon. My name is Laura.forni from the Stockholm Environment Institute. And in the next few minutes, I'm going to be presenting the work that my colleague Francisco.flores and I will be doing in the Kunduz River Basin as part of the SWIM project. In this video, we're going to provide a description of the Stockholm Environment Institute, or SEI, and our participation of the project. Then my colleague is going to present about the Water Evaluation and Planning Software, or WEP, for supporting watershed level decisions and irrigation management. And third, we're going to provide a description of the Kunduz River Basin that's going to be done by our local partner in Kabul. So the Stockholm Environment Institute is an international non-profit organization and is distributed in different centers around the world. There's one center in Africa, one in Asia, 4 in Europe, and those are the York, Oxford and Tallinn Center, our headquarters in Stockholm, and then we have the SEI US Center that is distributed between 3 offices. We have an office in Boston where our administrative team is located, an office in Seattle where our center director is located, and both of those offices focus mainly on energy, but there are other programs as well. And then we have an office in Davis, in California, and that's where the SEI US water program is mainly located, though we have some colleagues in Boston that are in the water program. In the last about 6 years, the water program has been implementing a process called robust decision support, and that has been implemented in various basins around the world, as you can see in a lot of basins in Africa, in Asia. A lot of work was done in Latin America and in the US. And the purpose is to work with water managers around all these basins in supporting the decision making in long-term planning. For that, the basis of this process, of the robust decision support process, is the XLRM. The XLRM is a problem formulation framework that starts with identification of the exogenous factors. These are the aspects related to uncertainties about the future. For example, changes in climate, precipitation, and temperature that would produce higher levels of evapotranspiration, and also changes in urban growth, for example, or in land use change in relation to different type of agriculture, more intensive or non-intensive agriculture, and also deforestation of natural landscapes. These are the aspects that are out of the control of decision makers, and that's why are exogenous factors. The next components are the levers. The levers have to do with the strategies to mitigate any negative impacts of those uncertainties in the future. One example, and that is circled in the picture in black, is, for example, the construction of a reservoir. So the construction of a reservoir that would try to mitigate any negative impacts or ensure a reliable water supply for the basin. So the other component is how all these aspects relate in each other, and that's where the WEP software come in that my colleague is going to be presenting next. Then we're going to identify with the stakeholders and local decision makers the metrics of performance. These are the AMPs, and they have to do with what are the key variables in a system that would allow us to assess if these strategies are effective or not, or what are the state of the current management of the system. For example, this has to do with the annual energy production for the reservoirs, or, for example, meeting the urban or irrigation demands in the system. So how is this robust decision support framework works for Afghanistan? This process starts with the preparation phase, and we're currently in this phase with this calibrating the WEP model based on historical conditions for the Kunduz River Basin. After we have a model that represents or is a good simulation of the basin, we're going to have a workshop with decision makers for the identification of these components, the XLRM components that I just described. After that, we need to gather any financial information of the proposed strategies, because the strategies that we're going to be identifying, they're going to be used as a cost-effective analysis. And also, we're going to be implementing the uncertainties and strategies in the WEP model that we've already developed. So this preparation stage will lead us to the investigation stage. That is starts with the execution of an ensemble of model runs. As you can see, contemplating these different uncertainties and strategies in the model ends up in several projections of the future. So in order to contemplate all this, we're going to do an ensemble of WIP model, and we're going to produce a relatively large set of results. And for that, we're going to use a visualization tool that will allow us to validate and analyze those results in an interactive way. And we're going to do that in a workshop that we're going to call the Robust Decision Support Workshop. And from there, we're going to be able to inform any decisions or any plans or strategies that Decision Makers wants to set up for the Kunduz River Basin. So now I'm going to move and leave the presentation to my colleague, and he's going to be presenting about the water evaluation and planning software WIP. Thank you.
Good afternoon. My name is Francisco Flores from the Stockholm Environment Institute. In the following slides, I'm going to talk about our model that is used in 183 countries around the world. The model has more than 26,000 users in the world, and all the information related to the model can be found at wip21.org. I want to highlight here that WIP is available for free for all users in developing countries that work for governmental agencies, academia, research organizations, and non-for-profit organizations. WIP stands for Water Evaluation and Planning System, and the characteristics that WIP has is that WIP is an integrated hydrological and planning model. The model has a GIS support interface. WIP can simulate both water supply and water demand, and internally WIP has different modules that can simulate, for example, the plant growth and irrigation demands, water quality, and financial analysis routines. WIP can also be linked to other models such as ModFlow, which is a groundwater model flow, or Qual2Cape, which is a water quality model. WIP allows the inclusion of user-defined routines, and one of the main characteristics about WIP is that WIP has a strong scenario management functionality. Some examples about the use of WIP around the world are related to topics related to sectoral demands, for example, agriculture, land use and climate change impact on hydrology, water conservation and water rights and allocation priorities, groundwater and stream flow simulations, reservoir operation and hydropower generation, pollution tracking and ecosystem requirements. In the context for the Kunduz River Basin study, WIP is going to use in the context of management and planning, and the model is going to use to provide a common framework and transparent set of data that can be explored by all stakeholders and decision makers. The scenarios can be easily developed and explored for options in the future, and implication on various policies can be evaluated. What is important to mention also here is that we will represent the key processes in an integrated management in the basin without going into deep consideration of any topics. Thank you.